Hello all, welcome to Coder. Today let us solve the lead codes daily challenge and the problem is continuous subarray sum. Given an integer array nums and an integer k, return true if nums has a continuous subarray of size at least two whose elements sum up to a multiple of k or false otherwise. An integer x is a multiple of k if there exists an integer n such that x is equal to n into k, which where the sum is going to be a divisible of k. If we can form that, we can form a subarray of sum which is a divisible of k, then we have to return true, else return false. And 0 is always a multiple of k. So let us analyze the example 1. As you can see, the example 1, the 23, 2, 4, 6, 7 and k, where k is equal to 6. You can see the subarray 2, 2 4, which is the sum of 6, is a divisible of k. So there exists a subarray sum which is a divisible of k, and in nums2 the sum of this total array is nothing but 23, 25, 31, 35, 42. 42 is a divisible of 6, and even you can say 6 plus you can say 2 plus 6 plus 4, which is also divisible of k, which is 12, which where the sum is 12. And uh, but you cannot say this 6 is a divisible of k, because they are asking us to form a subarray which is having a size at least 2 elements. So we should also take care what is the size of that subarray. It is a one length subarray, so we cannot say this is a divisible of k if this is alone given. So in example 3, you can never form a sum which is going to be divisible of k, which is 13. So they return false. So hope you understand the problem and it is a straightforward. They are asking us to return true if we can form a subarray sum which is divisible by k. So before jumping into this problem, let me give a give the small brute force approach. The brute force approach is nothing but surf through all the subarrays by multiple for loops, and we can find the total sum, and if the sum is divisible by k, we can return true. But this is pretty slow. And how we can optimize this approach? Before going for this optimal approach, let us go and see whether we can form a sum which is having a sum equal to k. That is, if I am given with array 23, 2, 4, 6, 7, then if I give a k equal to 10, then how you will say whether you can form a sum which is having having a sum equal to k. You can, what we tend to do is we will do a for loop and check for the sum equal to k, or else what is the optimal approach, that is we will be using a map and we will be storing the elements, and when we see the complement of that element is in map, then we return a true. The same similar stuff which we use in to sum using a map, the same similar approach we are going to incorporate in this particular approach. That is what I came to say this approach before. So we will be storing these elements in map, and when we see a complement 10 minus 6, which is 4, 4 is already in the map, so we return true. So similar stuff, how we can form the subarray. Subarray is nothing but, if I am at a of I, if I want the sum of I, what does this signify? Sum of 0 plus sum of 1 plus till sum of I minus 1. This is the prefix sum that I am saying. So this is the total sum of the total sum of that elements, where we get the sum of I. Similarly, if I want a subarray sum between the range sum of L to R. L to R, what does this signifies? Sum of L plus sum of L plus 1 plus sum of L plus 2 plus and so on plus sum of R. minus 1. This is going to be the total this is going to be the total sum of that particular subarray for the range L to R. So obviously what we can do is we will be finding the prefix sum of L to R. If I ask prefix sum of L to R, what I will be doing is prefix sum of R plus 1 minus prefix sum of L, so that we will get the total sum of the range L to R. So this is obviously one thing we can do. So I will rearrange this particular statement, which is nothing but prefix of R plus 1 equal to prefix of L, and we have to find, we do not want to find the sum of the subarray which is equal to k. We want to find the sum which is divisible by k. So I will take a mod value also here, mod k. So similar to sum, what we can do is, if I can store this particular element, which is I can store the modulus k, the element of mod k in one map, and if I see the complement, if I see the complement which is present in the map previously, then I can say obviously there is a subarray which is equal to a sum. So what is the approach of this solution is, I'll be using a map where I'm going to store the elements, mod k elements, into the map, and once I found that prefix sum already present in my map, then what I do is I can directly return true if my prefix sum is already present in my map. But I should take care of this case. The continuous subarray size should be at least 2. So how can I find that efficiently? I can store the index into the map, so that what I am the current index, the current index minus the MP of that element will give me the previous index, and if it is greater than 1, then I can just return true. So by storing the index into the map, I can easily say there is at least two elements present. So this is what the approach that we are going to do, going to code here. For that, I'm going to have an unordered map, int mp, and I will take the size of the array nums dot size, and also I will have the prefix sum element which is going to accumulate the total sum, which is 0. And now I will go to the index for int cur index equal to 0 from cur index is less than the size, and if my cur index plus plus. And while going and traversing the array, I will first calculate the prefix sum plus equal to nums of i is not current index, and I will also take the modulus value, prefix sum mod equals to k. Now I have taken the modulus value. Now I will check whether this prefix sum is already present in my map. So mp dot find of prefix sum is not equal to mp dot n. If it is already present in map, I should check the size. So check the size whether it is at least 2. So what I can do is the current index minus the previous stored index is going to be greater than 1, then obviously I can return true. If not, I'm going to store the current index. So mp of nums of current index, sorry, it is not, it is previous sum. If my prefix sum, mp of prefix sum equal to I, so I am storing the current index. Finally, if I couldn't find anything, I can return false. So, but will this be passing all the test cases? Definitely not. Why so? If my array is containing 0 as the first element, then obviously that 0 is going to be divisible by k, but we should take care whether the distance is also 2. So what we can do here is we can check for that case prefix sum is equal to 0, and if my current index is a positive integer, then I can definitely return true. And this is the approach. Here the time complexity will be order of n. Time complexity will be order of n, and the space complexity will be order of minimum of a comma n. So this will be the time and space complexity. And let us try to run the code now. Sorry, it is the current index. Okay, it gets accepted. Okay, nice, great. Let us submit the code. So hope it gets accepted. Hope you like the solution, and we are on a streak of 300 plus days. And hope you can let us see in tomorrow's Read Code Daily Challenge. Until then, bye.